Good morning, dear students. I hope we are doing well. Today is the lecture number 5. Okay, this class belongs to lecture number 5. Before we discuss lecture number 5, I would like to just recall what we covered in lecture number 4. In lecture 4, we started learning lexical analyzer, which is the first phase of compiler. We started learning that in depth. And there we have seen that how the lexical analyzer perform tokenization. And to do the task of tokenization, how it takes the help of two pointers, lexeme pointer and forward pointer, and through the help of them, how it perform tokenization. Apart from that, we also came to know that after finding a lexeme, how the lexical analyzer mapping the token type of the lexeme, or how it identify the corresponding token type of that particular lexeme. There we came to know that there is a tool called as Deterministic Finite Automata. Through the help of that tool, the lexical analyzer, it maps the lexeme with its corresponding token type. Okay, if the lexeme is let us say if the lexeme is A, then the token type will be an identifier. If the lexeme is a plus symbol, then the token type will be an operator. If the lexeme is minus, then the token type will be operator. If the lexeme is int, int, then the corresponding token type will be a keyword. Okay, and similarly, if the token type is 10, the corresponding if the lexeme type is 10, the corresponding token type will be integer constant. If it will be 10.2, then the corresponding token type will be a real number or real constant. Okay, but how this is happening? This is happening through a tool called as DFA. Okay, so today, yesterday we actually learned this theoretically. Today we will take one example under lecture 5 to know in depth how DFA is actually works. Okay, and yesterday we started what is DFA, Deterministic Finite Automata, and what are the different components of DFA. Like DFA has a number of states. Okay, one of the state will be an initial state, and there may be multiple final states or known as accepting states. Then transition when a DFA reads input, when it reads an input, then it start jumping from one state to another state. Okay, upon reading one input, it decide the next state of the DFA. Okay, the next state may be the old state sometimes. Okay, let us say the DFA is in Q0 now, initial state, and EPT consume or EPT-CAA. Okay, then it may go to Q1. It may jump from Q0 to Q1, or it may remain there in Q0. Okay, so this decision it depends on the type of input the DFA encounter, right? So then another component of DFA is known as accepting states. Okay, one is you may say set of states. then transition, and then the acceptance and rejection. Okay, that means here you can see final state or accepting state. Final state or accepting state is also a part of the state. Okay, but as you say that DF has multiple states, one of the state must be the initial state. So every time the things start from initial state. Okay. Yesterday I cited one example that if you insert your ATM card in the machine, okay, before you insert, the machine will be in ideal state. Okay, once you insert, the machine switch from the ideal state to the next state. Okay, and once you insert the card, it will switch from the ideal state to next state. Okay, and it will start reading the card barcode of the card. If the barcode of the card is correct, then again machine jump from the current state to the next state. And in that next state, it may produce a screen where it will ask you to enter, to choose a particular operation like cash withdrawal, okay, mobile pin sale, cash deposit, or fund transfer, card to card transfer. Number of options will be there. You might have observed number of options in the ATM. Then in that state, if you choose one particular option, then again the machine changes to another state. Okay, and similarly the machine can jump from one state to another state, and finally the machine will after dispensing the cash, the machine will goes to the accepting state. In the accepting state, the machine again it will go back to the, once you remove the card, your operation is complete. Okay, the machine will again reset to the ideal state or to the zero state. Okay, it may wait for another customer to come and insert the card and to perform different operation, maybe same operation, kind of operation, or different. In the same way, DF also work. Okay, so we have already seen them that DFA has multiple states. One of them is the initial state, and there may be one or more final states. And the transition is nothing but the movement of DFA when it jumps from one state to another state upon seeing an input symbol. And this jump how the DFA jump from one state to another state, it is solely depends on the type of input it reads. Right now, we'll see the example of DFA, how the DFA is accepting an identifier. Okay, we'll see that through the help of an example. So your doubt, if you have any doubt also, it will be clear. Okay, so you see this the heading is given DFA for identifier. Okay, we know that what is the rule of making identifier. The identifier, it must start with a letter, either a cap letter or small letter. Okay, the identifier, it cannot start with zero. It cannot start with the digit. Okay, rather it start with always. It start with letter. It may consist other characters. Okay, like digit and letter. But initially, an identifier. Okay, the start symbol of an identifier must be a letter. So here you can see the DFA. So here the start state. Okay, that is called as Q naught. In Q naught, from Q naught it can consume a letter. It can read a letter either in uppercase or in lowercase. It reads the letter and it goes to the final state. Okay, because if you write sir int a, yes, is a single letter, that can also be an identifier. If you write a float b, b is also an identifier, single letter. So So it consumes single letter, or if you want to add multiple letter like sum, SUM, then first you pass S, then here a circle is you can see one loop is there. It can consist n number of letter and digit or their combination. Okay, so and finally it is the loop is also reaching to the final state. So here the initial state is Q naught. From the initial state, the DFA every time reads a letter. Okay, after reading that letter, if there is a single letter available in the identifier, then it is going to the final state. No problem. Accepted. If multiple letters are also there, then in the final state itself, it has the chance to read multiple letters or maybe a digit and going again to the final state. Okay, so from Q0 read a letter, go to Q1. In Q1 read another letter, or it may then maybe further letters or maybe digit. Okay, like Psalm. Okay, Psalm _05. Okay, here special symbol is not mentioned, but you can mention or Psalm 05 or Psalm 5. Psalm 5 means what? Yes, first you read S, then come to Q1. In Q from Q0 you read S, come to Q1. In Q1 you read U, again you are in Q1. Again you read M, and still you are in Q1. In Q1 you read 5, and again be there in the Q1. That in the final state. Okay, so Psalm 5. Now the input is completed and the machine is in final state. That means the input is accepted. Okay, so like this for every key for every tokens. Okay, for every tokens, this DFA are already defined in the compiler, in the lexical analyzer. Okay, there is a DFA already defined to identify or to recognize an identifier. There is a DFA is already predefined to recognize a real number. There is a DFA is already predefined to recognize an integer constant. There is a DFA which is already present or predefined to recognize different types of operators. There is single DFA for the set of operators. There is a DFA. If it is plus, it will go to the final state. That means plus is a valid token. If it reads minus, it will go to final state. That means minus is also valid token. Okay. So similarly, DFA, different types of DFA for different tokens. Okay, try to understand different types of DFA for. Don't think that these diagrams are available. No, the tables are available. DFA can be recognized or it can be realized in two ways. One is diagrammatically, other one is that is called as in terms of tabulation. Okay, this diagram can convert to a table easily. Okay, so why I am not exploring all these things here? Because I assume that this subject is taught this theory of computation or formal languages and automata. Formal language and automata theory is normally discussed in second year, second semester. But this compiler design normally appears in third year, first semester. So this DFA, you can say DFA is a prerequisite to this subject. So here we needed to spend more time to realize, to take multiple examples on DFA and all, and other parts of automata, because we here I assume that it is already discussed. I'm just recalling and making you to recall what is the DFA, how it works. Still, if you are not understanding, you can comment me, okay, in the comment section. I'll help you, and I'll try to produce exclusive video on DFA and NFA or in automata theory. Okay. So more or less you try. So this is the working principle of DFA. So what I said, there are 6 tokens. Yesterday we identified one is keyword. There is a DFA already made for keyword, which accept all type of keyword like int, else, okay, enum, okay. Then these are the different types of keywords available. No? 32 keywords available in C language. Similarly, more number of keywords are available in C++. In Java, for all the keywords, there is one diagram. There is one DFA which is already predefined. Okay, you read the input and map that input, which DFA is accepting that DFA, that input. Okay, if there is something you read, something that means the lexical analyzer reads something that is called as let us call as A. Now the lexical analyzer try to map A with various these 6 or 7 types of DFA. Let us say one type of DFA which is made for operators. A is an operator? No. How can you say? No, don't say like that. First you match it. Take A and try to make A to be accepted by the DFA, which is made for operator. The DFA will never accept A. Okay, the DFA which is made for operator will never recognize A as an input. Then you come out, check with another DFA. The DFA which is made for keyword is the DFA which is made for keyword, is it going to accept or is it going to recognize A as a keyword? No. Finally, you see there is a DFA which is made for identifier. That DFA will definitely accept A because it is clearly visible in front of you. Okay, from Q0 you pass A and go to final step. But A is an identifier. So out of these 3, 4, 5, 6 number of DFA. So finally, you see that one of the DFA is accepted A, recognizing A. Recognizing in the sense what? After reading A, it is reaching to the final step. So it is recognizing A. Then find out what is the type of DFA. This DFA is made for identifier. So A token type is now identifier. In same way, many DFAs are there, and many in the sense what? These 6 DFAs are there. One is for keyword, one is for identifier, one is for special symbol, one is for string, then one is for constant, and one is for operator. These all together is nothing but the program, right? We cannot write program without keyword, without identifier, without operator, and without special symbol, okay, and without constant. These are the 6 keywords, 6 tokens, and without leaving them, you cannot write a program. That is what the first definition, what I said, a program is a collection of tokens. That is the very best definition for a program, right? So anyhow, so this is very clear, right? How a DFA works, and we have seen a DFA for an identifier. Similarly, you can imagine, or you try to realize with the help of pen and paper, okay, or you may take multiple examples, okay. You may Google multiple examples. You may find out from your textbook multiple examples at any type, any doubt comes, then you can comment me in the comment section. Definitely I will help you. Okay, we will discuss that particular topic if doubt comes. Okay. So this is so here one this DFA is recognized an identifier. Okay. Lexical analyzer reads that once that lexeme is identified, that lexeme is mapped with any one of the DFA logic present in the or predefined in the compiler. Okay, any one of the logic, DFA logic, whether the logic is made for identifier, operator, or some or constant, which logic is accept, that category of that particular lexeme is identified there itself. If the lexeme is accepted by identifier, the logic which is made for identifier, then the token type of the lexeme is identifier. If the lexeme is identified or recognized by the logic present, logic in the sense what? DFA. Okay, mind it, DFA. So the DFA made for operator, then the category or the class or the token type of that lexeme is operator. Okay, very good. Now let us move to the next slide. Here you see the entire thing, what I said, the entire thing is given in terms of a flowchart. And the heading is working of lexical analyzer using deterministic finite automaton. Okay, you see the step one, read the input. Input that is the source code is sum equals to 10. Sum equals to 10. Okay, when the system, I mean lexical analyzer read this, how it reads, both the pointer initially, lexeme pointer and forward pointer points to the first character of the lexeme. Okay, the first character, that is sum, that is S. Okay, then lexeme pointer will be constant and forward pointer will, after scanning S, then it will move to U, S U. Okay, because U is present in the second cell. Okay, as we have seen yesterday, one diagram. Okay, each character will be present in each cell of the buffer. Okay, so first S, then U, then it is scan M, S U M. After scan, and finally it will get, after M there will be a blank space. Okay, once the blank space or the delimiter encountered, then it will stop there for a while. Okay, that time is very negligible. Okay, we cannot predict. Okay, so it will stop and the three letters, okay, or the characters, okay, consecutively identified in between those two pointers will be taken as a lexeme. And once that lexeme is identified, then it will take that lexeme or the pattern of the lexeme. Okay, pattern in the sense that enter SUM, and the lexical analyzer try to check that pattern, which DFA logic is accepting that pattern. And I shown you the acceptance. Okay, moving from one state to another state. Finally, if it reaches to the accepting state, then that is called as the string is accepted. Okay, in the previous diagram we have seen how the strings accepted. Okay, yes, you see the second step, DFA moves from one state to another state based on the input character. If letters are read continuously, DFA recognize as an identifier. Okay, the diagram is same diagram is also given. Okay, from Q naught is the start state, read the letter and go to final state. If there is a single letter, if there are multiple letter, read and go to the final state. Again, in final state, you read another letter or two letters or three letter. Okay, because that is a loop. Loop means you can multiple times you can read and go to the same state. Okay, or you may read a digit. Okay, and finally you will be in the final state, or the DFA will be in the final state. Okay, once it is final state, that is that will be recognized. I mean the class in the sense the token type of that lexeme can be easily identified. Okay, if you are if you are sending or throwing something, if you are throwing something and you are looking forward that this ball is belongs to that person who can catch that ball. Okay, you simply, there are 3 4 persons are standing, you are throwing a ball, one person catch that ball. Other persons may fail, they could not able to catch, but one person catch that ball, means that ball is belongs to that person. Okay, that means that class of that ball is belongs to that person. Very easy. This very easy. Okay. Next, once that is done, third step is when delimiter found, until white space is appeared, it will keep on scanning each character, character by character. Okay. Once that delimiter or white space is found, it stop there for a while and it is checks. Is the current character is a delimiter? Yes. If it is yes, then it go to jump to the fourth step. What is the fourth step? Token mapping. Just now I said no. The lexical analyzer maps the lexeme to a token. Okay, to a token. That means which the logic of the DFA accept that lexeme token type is belongs to that logic only or that DFA only. Okay. So for every logic, every lexeme, there is a token. In this way, this is called as mapping. If delimiter is not found, that means scanning of character is still going. So you can come back and scan. Come back in the sense what? Come back. I mean the scanning is going on. Okay. There is a suppose POSION. Okay. POSI position TION. Okay. After scanning POSI, will you get a white space? No. That means this is the scanning is going on. You start from P, then O, then S, I, T, I, O, N. Final will be N. How can you come to know? When after N, when you scan the delimiter or a white space. When you encounter that white space, then POSITION will be considered as a lexeme. And for that, take that lexeme, map with the 6 different DFA logics are available. Okay, one is keyword, one is identifier, one is operator, one is constant, and so on. Okay, 6 different logics are available. You map, you check which logic is accepting that, which logic is accepting position. That logic itself is the token type. If the logic keyword is accept, okay, if the logic of keyword is accept that, then we can say position is a keyword. If the logic of identifier accept that, we can say position is an identifier. If the logic of operator, no doubt operator will never accept, keyword will never accept. Okay, position is not a keyword and it is not an operator. Okay, so you may try, or you may say that the system may, before getting the accurate answer, okay, the system might have tried, I mean, with all the logic. Yes, I can agree with you. There may be multiple attempts, and finally the system will reach to any one of the solution which is accepting which logic. Okay, that logic itself is the token type of that word. Okay, yes. And you see, once it is done, mapping done, then token is generated. Okay, token is generated means identifier. Okay, the lexeme type is sum or position, and the token type is identifier. Done. Token is generated, job is over. Then it store the token and the corresponding information, lexeme. Okay, and the token type of the lexeme and its value. Okay, the memory location, Everything it is stored in the symbol table. Okay, everything it stores in the symbol table. Now the job of lexical analyzer is over. Okay, because it is solely made to scan. This is also known as scanner. Lexical analyzer, the other name of lexical analyzer, remember the other name of lexical analyzer is known as scanner or called as scanner. Okay, it is simply scan and stores the input. Okay, it is recognize whether that input is a token or not, because a program is a collection of tokens. So it is simply recognize whether I am scanning a valid token or not. Okay, I am scanning a valid token or not. If yes, it will identify the corresponding identify the corresponding information related to the tokens and store them in the symbol table. Okay, that is called as tokenization. Scan the source code, okay, and identify for every word or every lexeme. Okay, lexeme is a set of word. Set in the sense there can be a single word, there can be two words, there can be single character or two symbols, or there can be multiple symbols or multiple characters. Okay, like int a means a single. The lexeme is single. Int is a lexeme. A is a lexeme. Int is what is the token type of int? That is a keyword. What is the token type of a? That is an identifier. Okay, if you write int a equals to 10, then here four tokens are there, because four lexemes are there. Int is a keyword, because it, after reading it, it will map with the logic of keyword. If it is accepting, then that is keyword. It is known to us and known to compiler also. So int, because it is predefined, int is a keyword. Then a is not predefined. It will scan a and check with all the diagram, all the logic, all the DFA logic, which is accepting. Definitely identifier will accept it. Okay, the DFA which is made for identifier is going to accept a. So a will be treated as an identifier. Then equal symbol after scanning equal, it will check with the logic of DFA. Which logic is going to accept equal? Obviously, the logic which is made for operator. Okay, so there equal symbol will be treated as an, I mean the token type will be an operator. Okay, then 10, because you wrote int a equals to 10. So 10, what 10 is what? It is a constant. Okay, it will never accept by the logic of keyword. It will never accept by the logic of identifier. It will never accept by the logic of operator. Okay, finally, you see it will be accepted by the DFA of DFA, which is made to accept a number, whether integer number and floating point number. There are DFA or hybrid DFA which is made in such a way that it can accept both the integer number as well as a real constant. Okay, integer constant as well as real constant. So 10 is an integer constant. Okay, it is definitely accepted by the DFA which is made for constant. Next, semicolon. Semicolon is not going to be. I mean, it is not going to execute. Okay, semicolon will be removed. Okay. Yesterday we discussed, no, while scanning, it remove white space and some special symbols. I mean, some terminator. Okay, it remove them. Okay. So int a equals to 10. Int a equals to 10. 4 lexemes, 4 identifiers. One is keyword. Another one is identifier. Sorry, 4 lexemes, 4 tokens. One token is keyword. Second token is identifier. Third token is operator. Fourth token is constant. Is that clear now? So once this is done, the work of lexical analyzer is complete. Okay, and it stores everything in the symbol table. Okay. Now the work of syntax analyzer get starts. Okay. Here now the new topic, okay, is or the new phase that we are going to study in depth is syntax analyzer. What is syntax analyzer? A syntax analyzer is nothing but it is the second phase of compiler. It is also known as parser. Okay. It receives tokens from the lexical analyzer. It is written, but not directly. Rather, it is received through symbol table. Okay. So it receives tokens from lexical analyzer. It checks whether the token follow the grammatical rules of the programming language. I mean, after receiving all tokens, okay, it checks the tokens are arranged properly or not. I mean, whenever we are writing something or saying something, the sentence must be correct, right? So that others can easily understand. But how can you say that the sentence is correct? Only when if you can have some grammatical knowledge, you can able to form the sentence. Okay, I mean you can able to club those. I mean all the words. Okay, one after another through the help of grammar. Otherwise, yeah. Otherwise, if you randomly, I mean, mix the word, the sentence may not be a suitable one. That will be grammatically ill, and people cannot understand that. Your audience cannot understand. Okay. So it is so that is why whenever we are speaking either natural language or English is also natural language. I mean Hindi, Oriya, Telugu, English, Marathi, okay, Bengali, whatever the language we are speaking, natural language, or we are writing Hindi, okay, all these things. So we are speaking properly. If we are speaking properly, that means you have the idea of grammar. You know how to arrange the words so that a valid sentence, correct sentence can be formed. Without grammar, you can't do that. Okay. So it checks that sentence. Okay, sentence is okay, but is the sentence is grammatically sound? See, int space a semicolon. If I will write semicolon a int, is the sentence will be correct? You check it. Type it in your system and check it. That will be totally wrong. But those three symbols are there. Int is there, semicolon is there, a is there. There will be no change in the content, but there is change in order. Order means there is a grammatical order. Okay, that is why the sentence what I said second time will be the wrong one, and the first one will be the correct. Okay, so it checks that sentence is written correctly or not. It verifies the correct structure of the statement. As I said, it generate the parse tree or syntax tree as out. To check that, it perform lot of activities, and finally it produce one tree that is called as syntax tree or parse tree. Okay, the role of syntax analyzer. The syntax analyzer, it checks the correctness of the syntax, correctness of the syntax. That means grammar. Okay. It detects the error if any error is there. It ensures proper arrangement of tokens. Just now I said that. Tokens are arranged properly or not. Int should appear first, then a, then semicolon. If you write semicolon first, then a, then int, the three words or three lexemes are same, but their arrangement is wrong. So the sentence will be wrong. Okay. It ensures proper arrangement of tokens. It builds hierarchical structure of the program. It passes structured representation of semantic analyzer. Once it checks everything, okay, then it pass that structured representation means the syntax tree. It is a structured tree, okay, properly arranged. That a tree, not exactly tree. It is a tree. It is a data structure, okay. It uses the tree data structure in order to analyze whether sentence is properly arranged or not. And finally, it passes the tree as an input to the next phase, that is called as semantic analyzer. Okay, so we'll be discussing this lexical analyzer in depth. Okay, in the next class, I mean in lecture 6. Okay, here how from here onwards we will discuss working principle of syntax analyzer. Okay, so let us stop here. I wish you all the best. Have a nice day. Okay, so we'll meet in the next class. Okay, bye then. Take care.